Alrighty then, and welcome to the Daily Space Weather Show. I'm your host, Dan, aka Smash-O-Mash, bringing you spectacular footage, everything from filaments to massive active regions to the likelihood of X-class solar flares, the likelihood of solar energetic particle events, and that's just to name some of the things that we'll be blasting through. Here we've got a massive plasma filament in the foreground and then one in the background as well. See that foreground filament? It's just it's spectacular. So you've got a close-up of that in your lower left, and you've got this background filament which is still hanging out as a crown prominence around the solar north polar region. There's a zoomed out view of that. Keep in mind these are not 24-hour videos. We have 15 frames per second here for these. These are about 12 hours from today, April 17th. So there goes that filament. That was and still is, by the way. Part of that filament remains intact, it looks like to me. It's the Wout Artie Noobs filament, named after one of our viewers. Meanwhile, this sunspot down here is very likely to produce an X-class solar flare as it moves closer and closer to the Earth-facing portion of the solar disk. So it's got unstable plasma filaments and unstable magnetic fields of opposite polarities, which we will show you details about as well. We've also got CMEs popping off, as we cited yesterday. So, and guess what? One more is on the way. Now we can expect another, that's I think 5 possible CME impacts in the coming 3 days. So by the 20th, we could see as many as 4 additional CME impacts. There was a moment there when we were expecting 5, but I think 1 showed up early, something. I mean, you got to watch previous daily space weather videos if you want to see what the previous forecasts were. We can't keep bibliographies of our own statements. That's what the videos are for. So anyway, there is that's 304 angstroms, and let's show 335 angstroms for once in our lives. There's 335 angstroms, and with so much action going on, it gives us the opportunity to show some things we don't normally show, close-ups we don't always show on the channel. It's super exciting. We'll get back to space weather in a minute. First, some stuff going on planet Earth. That massive cinder cone at the Reykjanes Peninsula. It is simmering down, folks, but still some fantastic imagery there. An absolutely surreal scene going on in Iceland. So here's a zoomed out view if you want to check that out. And you can see things are certainly cooling down there. That was pretty sweet, right? We actually showed the evolution of that cinder cone on the channel for a few days. Please bear with me. Dear God. Dear God. And as far as what else is erupting, it includes Abiko, Ibu, Luatobi, Luatolo, Semeru, Tacono, Fernandina, Sancho Guido, Fuego, Novato de Ruiz, Sangay, Ravenador, and Sabancaya. That is quite a list. There was also a 6.3 magnitude earthquake near Japan. That's the past 90 days of seismic activity. And by the way, by covering earthquake activity, we're not suggesting that space weather causes earthquakes or can be used to forecast earthquakes. Maybe, but if so, send us a signal. Tell us exactly what signal you're using to do this magical alleged forecasting for earthquakes, because we hear lots of claims, but we don't see anybody actually doing what they claim they do. So that's the issue that we have when people are like, hey, I know a channel who forecasts earthquakes based on this or that thing going on. It's bonkers. Anyway, it's not even really worthy of a debate in most cases because people don't even have a coherent claim to make. They're like, a dude forecasts. Anyway, these are the 5 and greater magnitude quakes. There's one in the Bay of Bengal near India. Here's one in the Bellini Islands in the Southern Ocean there. That's a very, very rare spot for a quake, I believe. Also, Taiwan had a 5.0. But the most important one is that one right there, near the Isle of Kurojima, a 6.3 magnitude quake. And it looks like, according to the pager, it would have done some damage there. No, maybe not. It's looking pretty harmless, folks. And what else do we have? That's it. Those are the 5 and greater magnitude quakes. More space weather to come here in a minute. But first, let's pause for station identification. You've reached the Smash News Network, least busted name in news. Here's our house favorite wavelength. And yeah, that sunspot down there in the southeast, that is certainly the place to watch. The possibility of X-class flare is very high. Also, we have a likelihood of proton events as a result of that setting sunspot in the northwest. That would be your upper right, the northwest, the portion of the sun where sunspots set. So here's a close-up of this. That's actually 2 separate named sunspot groups. It's the trailing one that is the real flare player, but the leading one also has some complex fields, which we will show momentarily. 171 angstroms is very nice. It shows the lower corona. That is 15 frames per second over a period of, I think it's almost exactly 12 hours there. 0800 to 2000 universal time on the 17th April. So a very picturesque group of sunspots, and it is quite a magnetically complex group of sunspots, as well as it has a very large number of individual umbrae. 10.7 centimeter radial flux is now just under 200. Sunspot number is now over 200. We'll get to that here in a moment. There's the radial flux over the past year. 199 solar flux units is the radial flux density being measured by the 10.7 centimeter radial flux. It's that's multiply that by 10,000, and it's that many Jansky. Jansky. That's what a solar flux unit is. All right, so here is our Space Weather Enthusiast dashboard, and as you can see there, it looks like NOAA's under forecasting here. I think they may have missed a CME or 2. They have been stealthy ones. A little bit hard to see. There is very little contrast when there's concentrated gas kind of diffusing right toward you. It can be very tough to spot. So give them a break. There's the forecast from NOAA, their Enlil spiral. And only expecting an impact there on the 18th. We're expecting more impacts on the 19th and the 20th. So as many as 3 more that are not shown on NOAA's forecast. Now, the ESA's forecast is looking a little more consistent with ours, although they've got 3 of those events combining, and it has to do with CMEs leaving the corona at different speeds. That is a lot easier to do if you have access to things like the data from the solar orbiter. I may be able to actually forecast on that resolution, but I suspect that ESA is using solar orbiter, Parker Solar Probe, and I think Bepi Colombo may have some instruments that are useful. Is that the case? Let us know in the comments. I'm not researching Bepi Colombo while I do the space weather, but Yeah, there are a couple spacecraft that could be helpful in determining the speed of CME impacts. Anyway, here are the past 4 hours of Earth's magnetic moment from space, and it is calm. So we have had some variations happening with the solar wind with some CME impacts, but none have been the type that would produce solar storm conditions. So no geomagnetic storms have been induced lately, not since around when we made yesterday's daily space weather video. So here is Earth magnetic moment from the ground for the past 4 hours. And yeah, I would just have to say that, again, it is geomagnetically calm. So we'll show you those variations in the solar wind here in a moment. KP index is at KP 1.66, so very calm, very calm. Just a brief period of G1 minor KP5 geomagnetic storm conditions right around yesterday's video. And guess what happened? It subsided rapidly, just as we forecasted in the video. Anyway, or I should say as I forecasted in the video, that was definitely not a group effort. I did all of the analysis and writing of that forecast all by myself. So anyway, here's the ACE. And you can see there has been an additional CME impact here just in the past few hours, a completely different magnetic regime, solar wind density, but a similar speed there. So, but a big shift in the magnetic fields. Plasma temperature also shifted there. You can see some step-like features in the plasma temperature, which is that lower green line. So we'll call out the numbers for the Discover, though. Let's see. So here's a CME impact, very clear on the Discover, right around 9 o'clock Universal Time this morning. So right around 0900 Universal Time. That's another CME impact. And then looks like another one here. So multiple minor impacts coming in here at the same time. Again, just like ESA has forecasted here, there is a significant likelihood that there may be some co-interaction. CMEs, they're able to, sometimes they practically pass through each other, I would suspect. Other times they'll interact with each other. They can sort of combine their efforts. They can sort of de-amplify their efforts. It's very diffuse gas, and the way they interact with the relative vacuum of the less diffuse space that they occupy is subject to a lot of different terms and conditions. I'll just say it's fairly complex what a CME does as it blasts through space. So, but anyway, current conditions are about 5.5 protons per cubic centimeter. Solar wind velocity there, 372 kilometers per second. And we did see a slight intensification in the magnetic fields there, but we still have a positive BZ. So, again, we don't have the conditions you'd expect to see geomagnetic storm conditions. However, a minor shift in some of those factors could indeed sprout some minor geomagnetic unrest or geomagnetic storms. Again, multiple additional CMEs incoming, as many as 4, as well as a coronal hole high-speed stream around the end of that feature. Anyway, here are GOES magnetometers, and yeah, you see some sawtooth readings there. You see some satellite maneuvering marked by those arcjet moments. Things are getting a little smoother here in the past 12 hours or so, as things have been rather chill for space weather. As far as magnetic sectors, Earth is still in a south pole magnetic sector, shown there in red. Pretty clear, no real explanation required. Here are the solar fields. If you know, you know. B field in blue, polar fields in red and green, photosphere magnetism, where sunspots occur in grayscale. Coronal hole magnetic line of sight field plot. The coronal holes are essentially the sites of the polar fields. The B field is sort of the field that goes through the magnet, this magnet being the sun, and that's really all that's depicting. So let's take a look at coronal holes from the perspective of the Smash News Network, least busted name in news. There is the picturesque 211 angstroms wavelength. And it is a strong South Pole-oriented coronal hole there, folks. Just a few degrees south of the equator. And, yeah, that is likely to become geo-effective in terms of providing a fast solar wind in something like 3 days. Fast solar wind preceded by a density spike in the solar wind, the characteristic and telltale feature of a coronal hole high-speed stream. So moving on to sunspots, and what do you got? What do you got? You got over 200 sunspots. That's what you got. So there you go. Over 200 sunspots. Sunspot number currently at 209. 209. So that's a pretty high number of sunspots, wouldn't you say? All right. And by the way, if you enjoy the content, make sure you press the like button. If you're new to the channel, press subscribe. Otherwise, I could sink into my S-bars. Don't make me sink into my S-bars. You see folks in the bunker at SNN? We have the swamp-based acceleration reduction system, or S-bars. We've built a swamp on the lower levels of the bunker because we didn't want to construct a fire pole. So for fast access to the lower bunker levels, you just jump through a hatch in the floor, don't skin yourself alive while doing it, and then land in the S-bars, the swamp-based acceleration reduction system. So we may consider providing full plans for the bunker. After all, you're allowed to know what it is as long as you don't know where it is. Doesn't really matter. So, yeah, but if you're new to the channel, press subscribe. Press the comment button if we've made you angry with factual depictions of things for, well, half a decade at this point. We encourage all rage comments at the Smash News Network. Leads Busted Name of News. All right, and let's blast through our sunspot coverage, as that's a lot of sunspots. That's what over 200 sunspots looks like. So yeah, there's that. And like I said before, very high likelihood of X-class solar flares, especially from sunspot 3643. 3643, and also the leading sunspot there, 3638. 3638 and 3643 are both big flare players, and 3634 is also in the running. So multiple areas there, though, that can produce large solar flares. So I'll just leave it at that, and let's cut the sunspots. Dag! Sunspots are bonkers! Look at the number of sunspots in that southeastern quadrant. So here's our magnetogram. And let's just show the close-up of the magnetogram there. And we've rotated the field of view. If it looks strange, it's because the sunspots aren't moving, but the sun is, to facilitate their stationary. And check it out. It reminds me of the comic Spy vs. Spy from Mad Magazine. But anyway, there's quite a bit of magnetic shear there in at least two different locations. Namely in here. And in here. And there's some motion happening there. So those are unsustainable magnetic field scenarios right now. That'll find a way to either produce a big flare, or those fields could move into a situation where they could just sit stable for a long period of time. So you never know, but at the moment, likelihood of large solar flares with the configuration they are currently in is really high. So flares are coming next. Flares. Sup with flares? Well, it hasn't been that flary. We don't have any proton events here for a while. So there's the proton flux. No spikes there. Just one M-class event here in the past 24 hours, or that was maybe C-class. Barely M-class. C9.72. I think it's a C9.72, so a nearly M-class event there. Not sure exactly where it came from, but let's take a look at the thing. The thing at the place, you know, The place? Yeah, the place that has the thing. SNN, least busted name in news, has a thing. And it's the most incredible solar imagery you'll see anywhere. And there are those highly magnetically complicated sunspots. So that's actually 3 named groups. 2 in the lead and then 1 trailing, which is actually the most magnetically complex. And it looks like that C-class flare did come from the southern part. Indeed it did. That C-class event came from the southern part. That C9.72 flare came from right down in here. So, but there's a lot of plasma instability going on around there. And of course, that does affect the fields. As the plasma aligns to the magnetic fields, they are massive, massive sections of matter hanging out down there. And of course, the ions that you're looking at there are iron. So that is some heavy gas. That's iron at millions of degrees. And 131 angstroms, the wavelength we're showing here, is the hottest of the SDO AIA wavelengths. And just so you know, if you ever want to look into that, you can just go to the SDO website. It's super convenient. Just hit up the SDO website, and here's what 131 angstroms is. It is, you click the little I there for info, and it is the, there we go. So about 10 million Kelvin, or 18 million degrees Fahrenheit. It is 20 and 7 times ionized iron. So iron, that's iron 8 and iron 19. Iron 8 and iron 21, rather. So that's what 131 angstroms is. And let's move on to we'll get to CMEs here, as there is at least one more headed this way, possibly 2, but I think just 1. Here's our solar system forecast. That's where things will be on the 24th of April. Looks like full moon is approaching. Here is what's going on overhead right now, our star chart, and if you're up early tomorrow morning, check it out. You'll get a great view of perhaps Mercury and Venus there. They'll be very close together in the sky, right behind Saturn and Mars. But there you go. Look at that sunrise. Mercury and Venus side by side there on either side of the ecliptic tomorrow morning. If you're up before dawn, check that out. That'll be fantastic. Here's our astronomy photo of the day, also spectacular. And yeah, so 2 comets, including a sun grazer, photographed from the ground due to the eclipse. So there's Comet 12P, and here's Comet Soho 5008. And that must have been the sun grazer. It disintegrated. So also Mercury and Venus. Just an insane scenario there. Just freaking awesome. And so, anyway, there you go. That's the astronomy photo of the day, apod.nasa.gov, if you want to download that image yourself or look at it up close. Here come CMEs, and literally there are like 4 on the way. So here are today's frames. And we paused this morning because the latest Earth-directed CME was from this morning, early this morning, around 3 o'clock. We started to see it emerge, and it looks like there's a hour and a half of missing data there, and then it comes back. So, but that's the scenario. One more CME expected to arrive sometime around midday on the 20th. Midday the 20th, folks. Another one likely to show up. Now, again, like I said, ESA may have better insight into the speed of each individual CME. That is not my specialty, especially without the ability to have stereo A at a wide angle. stereo A right now is very close to Earth, as you can see. And that right there, that red A right there is stereo A, and it's not very far away from Earth. It doesn't have a lot of angle, so it's very hard without accessing. I've got to look into that, being able to forecast the actual velocity of CMEs. Admittedly, not my specialty. So, but I think I may know the right people to talk to on places like Twitter. And of course, some of the data is publicly accessible, so I suspect Solar Orbiter may have some data. I know there's a guy that reports on it on Twitter. So, but anyway, here's stereo A. And that's still yesterday. But you should see early this morning. Oh, that's pretty lousy. A bunch of missing data there. So, and I think there were two events going on at the same time. One is on the far side, but I'm not really going to worry about it too much. It'll be a fairly minor impact. It wasn't a major CME in the first place. But here we go. There are our custom coronagraphs, and we missed that when you're seeing it. You're seeing it exit the corona there. It's that CME happened before this footage started. So the one that's coming out of the south there, that really doesn't. That one doesn't eject, I don't think. But there was one that came out of this area up here, and that one did eject. Anyway, we're going to close out our custom footage here and get to meteorology. There is our extreme close-up of that spectacular series of 3 named sunspot groups. Just bonkers. Completely bonkers footage. And let's move to filaments. So here are filaments from, I don't want Big Bear, I want Cerro Tololo. Cerro Tololo, Chile. There it is. And lots of filaments still litter the Earth-facing portion of the solar disk. So the likelihood of additional CMEs in the coming days is still nearly 100%, especially with such a high likelihood of large solar flares. So lots of stuff going on. Lots of stuff going on. And there you can see that huge vote. What is it? Vote Arty Noobs. WOT Arty Noobs. World of Tanks. If you like watching great tank warfare, that filament, it's largely gone. There's still a tiny remnant of it there, but that filament has blasted off, and part of it is headed in Earth's direction. Love that. It's basically artying the Earth. It's doing an arty strike, which couldn't be more fitting. So yeah, we've also got this crown prominence. This is just the past couple of hours from the GOES 16. Let's go through our bonus features very quickly here. Satellite charging hazards. By the way, if you want to name filaments, follow the hashtag name that filament over on Twitter. x.com/smashomash. Satellite charging hazards are first. We ain't got none. It's smooth sailing for satellites. The GOES electron flux is next, and it's kind of low, as we've been seeing some geomagnetic storm type impacts. So that'll be marked with an increase once things calm down, which is going to take several days, and then we're going to see a big increase in the electron flux. Here's NOAA's forecast model, and we're still 3 days out from the last impact, and it'll still take another 2 days or so for that to return to normal levels. Here's the layer where it's measured, the F layer of the ionosphere. And that's a thing that I have to load, because if I don't load it, then there's nothing to see. You see? There you go. There's the ionosphere. And yeah, we're going to see a bunch of low-frequency anomalies in there. I mean, that's sort of what you'd expect, since the previous day included a mild geomagnetic storm. So it won't be anything extreme. It'll be mild. That's why I use that terminology. And if you're spooked of space weather, then it's it's very sad. I don't know who has spooked you of space weather, but it's kind of not going to end civilization. I suppose it's theoretically possible, but there has to be a mechanism for that, folks. So extraordinary claims require extraordinary evidence. I'll just leave it at that. So yeah, there's the anomalygram anomaly in megahertz from a 30-day median. Low frequency in red, high frequency in blue. Here's a global ionosphere nowcast, which I'm not even going to show because I'm running tight on time. Here are the magnetic fields to keep an eye on. And when I say ion, well, the pun is intentional. So really, both of these groups here, these southern groups, this one's actually looking like it's picking up some action too. So lots of stuff going on. Also, this group could produce a large solar flare just due to its proximity to the limb. That increases the likelihood. And up here, we've got some magnetic complexity as well. So, yeah, lots of stuff going on. Here comes meteorology, starting with the All right, that's what we're talking about, a high-speed weather forecast. So here's the whole planet. Jet streams first, surface winds next. There's a central world. And there are the jet streams. Jet streams of the west, right there. And surface winds, right there. Satellite imagery of the west. Not half bad. Not bad at all. Next, radar. No, you can't know my location. Go away. Go away. That's a U.S. radar. Here's our weather.gov map. Weather.gov. Severe weather across Ohio and western Pennsylvania. Tornado watches over a large part of the country there, including parts of West Virginia as well. National Weather Service's homepage is weather.gov. Go there if you need a forecast, and go to Tropical Tidbits if you want to make your own, like this one right here, the 72-hour GFS pressure and precipitation forecast. Again, this is what we call a high-speed weather day. High-speed weather because we had so much space weather stuff that it took a lot of our time up. So there you go. Here's our lightning over the past 10 hours, and as you can see, major stormage there moving toward Pennsylvania. At the moment, we do indeed have some lightning, and it's south of Erie, in places like Cleveland. Cleveland, you are in the crosshairs. Worcester, dag. See, that's the kind of storm that produces damaging wind and hail. And funnel clouds. Funnel clouds. So that's another one there. North of Columbus. Another supercell. Look at the concentration of lightning there. That is a good place to not be. Don't go riding your steel bicycle on a day like that. Dag! Don't get struck by lightning, folks. It's not like in the movies. You're likely to have your last lightning strike ever. Your first is likely to be your last. I'll just say that. I'll keep it vague. And what is going on with the son of a... All right, there we go. That is the full 50-state view. We're going to focus on the lower 48 view as we do. Again, strong storms there. I showed you the warnings, so heed my warnings and press the like button lest thy soul be cast into an ever-deepening and darkening abyss of low magnetic field intensity and very spooky cosmic ray influx and all kinds of other spooky things that you'll be spooked of. You'll be spooked. You'll be spooked. Here's our visible satellite image for the lower 48. And here is our water vapor map for the lower 48. That little finger of dry mass of air there, once again, you can see it acting like a wall, separating the moisture from the other moisture. Just a fantastic example of that dry mass of air being in control of things, high pressure. It has a tendency to push the rest of the air around. And of course, the jet stream is responsible for making your weather move from west to east. Here's our Doppler radar. There is our satellite. There is our water vapor map. Thanks for tuning into the Smash News Network. These parts of the name of news. I've been your host, Dan, a.k.a. Smash-O-Mash. It's time to use the S-bars once again as I descend back to the bunker. And until next time, may that solar wind be at your back. Back to the bunker. Whoa!